that you've had a chance to write some of this stuff down, you gotta keep in mind your Latin prefixes. Mono, one. A monomial, it says it's a number, it's a variable, or a product of a number and a variable, or one or more variables with whole number exponents. Whenever you have a collection of numbers and variables to powers, things of the such, it is simply going to be looking something like what we've got right here. Okay? No addition or subtraction. One of the ways to go and identify a polynomial is that you've got a bunch of things that are being added or subtracted. Okay? That cannot be simplified. So if I look at this one down here, I got this minus xy cubed minus 3x squared y squared plus x squared y cubed. This is a polynomial. Why? It's made up of poly, which many of the monomials. Okay? Degree. The degree is always going to be the sum of the highest exponents. So if I look over here, for this one, I got a 1 and a 3. I added 1 and 3 together and I get 4. That's a fourth degree monomial because there's only one of them. I look at the polynomial down here. Well, that's 1 and a 3 is a 4, 2 and a 2 is a 4, 2 and a 3 is 5. This is a fifth degree polynomial. Okay? We always identify the highest one. Okay? Now there's one other thing that we are going to be looking at, and that is putting things in standard form. Standard form is generally the idea that we are going from the highest degree polynomial to the lowest degree polynomial in alphabetic order. Okay? So, let's take a look at this and what a polynomial actually really looks like. Whenever we do a polynomial, it is going to follow this form. A sub n x to the n. A sub n minus 1, x to the n minus 1, plus dot, 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 all the way down to a sub 0. What does that mean? All that the n is doing there, it's taking, hey, this is the nth degree polynomial. It's just counting them. Meaning that this is different than that, which is different than that, which is different than that. They're all different. It's just counting them out. You know, first one, second one, third one, fourth one. Okay? Item A, item B, item C. Doesn't matter what it is. The leading coefficient, when we use that word, leading coefficient or just coefficient, we're looking for the number out in front. Now, the last term is always going to be a constant. It will not have a variable. So, what I want you to make sure that you have down is have this pattern written down because we will be going back and using it. Okay, let's take a look at the next section here. Now, I want to write this polynomial in standard form. First thing that I want to do is find which one of these has the highest exponent. Okay? Degree term. I've got an x, I got a minus 5, I got a 4x squared, I got a 2x to the fifth, and I got a minus 2x or minus x squared. So when I look at this, I see that the highest one that I have is right here. Whatever sign is in front of it, we want to make sure that stays with it. If it's positive, we leave it positive. If it's negative, we want to put the negative sign in front of it. So this would end up getting written down as 2x to the fifth. Okay? First thing. Now, I look for the next highest exponent. Well, the next highest exponent I see is here. X squared, but I also have another one there. Okay? So what I want to take a look at here is if those things are the same, we're going to be taking a look at what are combining like terms, and you've done this before, Algebra 1 stuff. Those things that are the same may be put together. So if I got 4x squared minus x squared, what number would be in front of that plain old x squared if I needed one? It's going to go to 3, but what would I be putting here first? 1. So that would be a positive 4 minus 1, so that would give us our plus 3x squared. Those things that are the same are combined. Because I got 4 of the x squareds there, and I'm supposed to take away 1 of the x squareds over there. Okay. Now, next thing, what's left? Well, I got a plain old x and I got a plain old 5. Well, that x is positive, so I would put down a plus x. Last thing I would have is minus 5. Now, this is written in standard form, starting with the highest exponent, going all the way down to the constant. Okay? So, now, it asks, what is the leading coefficient? Well, the leading coefficient is right there. Okay? So the leading coefficient here is a 2. First coefficient out. What's the constant term? Constant term is right here, which is negative 5. So we got to keep the signs with things, but it's just simply putting them in order, descending order of the exponents. Seem easy enough? On the surface, right? Okay, let's look at this. Now, polynomials can be classified degree and by the number of terms. Okay? So, if I want a polynomial that's just a constant, it has 0 degrees, 1 term, it's a monomial, just all by its lonesome. If I have one plain variable by itself, this is a first degree polynomial, linear. If you remember your equation for a line, y is equal to mx plus b. It has just one x in it. It forms a line. Number of terms it'll have maximum, 2. It'll have an x term and a constant. Next one down. Well, if I have an exponent of 1, what comes after that? What's the next highest one after that? X squared. So that means I'll have an x squared, I can have an x, and I can have a constant. What's the degree of this polynomial? 2. Why? Because 2 is the highest exponent that you've got. This is called a quadratic equation. Okay? Quadratic because second degree polynomial. How many terms can it have? 3. This would be a trinomial then. Now, if I take a look at this next one here, it just has x cubed. Does it have a squared term? Does it have an x term? Does it have a constant term? Well, in reality, it does. Because this could look like this: x cubed plus 0x squared plus 0x plus 0. Everything else is zeros, but they can still be there. When we get to division of polynomials, we'll have to learn about making sure that every place is there. So, what is the degree of that polynomial? Well, what's the highest exponent? 3. So it's a third degree polynomial. Third degree polynomials are called cubic. How many terms does this have? Well, it's only got one term because these are all zeros. When we have 0 terms, it's kind of like having 0 money in your pocket. Do you have any money? No. Do you have any more terms? No. You just have the one term. So this would be classified as a monomial, single term. Now if I look at the next one, now I've got it to the 4th power. Okay? So what's this degree? 4th degree polynomial. They call it a quartic. Number of terms that this one has? 3. Its constant would end up being a 0, wouldn't it? Plus 0 at the end. There's nothing there. 3 terms together, we call those trinomials because there's 3 of them. Next one. What's the highest exponent you see? 5. So what's the degree of the polynomial? 5. Classification by degree is quintic. And no, you don't have to worry about those words. They just have them there so that they do actually have words. There's all kinds of nice words in math. Number of terms is 2. Classification by terms is binomial. Why? Because there's 2 terms. So, if I go on to this, and we need to be able to identify the two things. Okay, what type of is it, and what's the degree? So the degree here, what's the highest exponent you see on A? Well, I see a 2, so that means that this is a second degree polynomial. How many terms are there? 2. So how do I list this? That's a binomial. Okay? Now, you need to be able to identify these things because we have these wonderful things like a binomial theorem. We have wonderful things also for factoring with binomials and quadratics. There's all kinds of little things and rules that are out there for this. So we need to be able to identify what they're going to be. So, the next one. If I take a look at this, what is the highest exponent I see? 5. So this means that this is a 5th degree polynomial. Okay? How many terms does it have? Well, if I count it, it's got 1, 2, 3, 4. However, is this and that the same stuff? They're like terms. So because those two are like terms, this is really going to be a trinomial. Okay? Because it would only have 3 terms because those two could be added together. So it would end up looking like negative 1 x cubed plus x minus 1/2 5 to the 5th, or x to the 5th power. Problem is that's not in the proper order. Correct answer, if I wanted to write this and rewrite it the way it's supposed to be, would be negative 1/2 x to the 5th minus 1 x cubed plus x. Now, in reality, would I need that negative 1 there? No, I just need the minus sign there. Like I said, these things look ugly, but they're fairly easy to deal with. Adding. Okay? One of the things I tell students that you got to keep in mind is parentheses are like a bag or a box. You got a bunch of stuff in it. Okay? If you're going to add a bunch of boxes with a bunch of stuff to it, you just end up putting things together, correct? So, those things that are the same still get added together. But when I go through this, I take a look at this, and I tend to underline things. I got color here that I can get by with here. So, I got 2x cubed. Do I have any more x cubed terms? And the answer would be no. So I will have 2x cubed. Okay? It's the highest one, so I want to start with the highest one. What is the next largest that I see? Well, I see an x squared here. I see an x squared here. Are those two the same? Okay, so I can add those together. Minus 3 minus 1 gives me a minus 4x squared. Done with those. What would be the next highest exponent after x squared? Well, it would be plain old x, and I got 1, 2. So I just put 3 lines underneath it so I identify that. So I got a plain old x there. I have no more. So this would be plus x. Now, I got a constant here and I got a constant there. Negative 5 plus 5. Would I have anything left? That's it. That's all it is. Now, this only works with addition. If I am doing subtraction, subtracting 2 polynomials, I've got to keep in mind that I'm taking away a whole bunch of stuff in the box. Okay? So every piece that's in that box is going to get taken away. So when I've got this negative on here, remember this little thing called the distributive property? What you want to do is take this negative, whenever you've got a negative out in front, give it to everything on the inside. Now the 5x cubed minus 3x squared, there's no sign out in front of it, so they stay the same. So I've got this minus sign. I want to take it away here, so that means it's going to be minus 2x cubed. Would that make sense? Because I'm subtracting everything on the inside. So I got to subtract that. Now if I put that negative over here, I got two negatives. What's that make it? Positive. So that would be plus x squared. Okay? Because that negative goes to there, negative 2 goes here, positive. Now that negative also goes to the 4. So that means that it's going to be negative 4. So you're just really putting that negative onto everything that's in that box. I got to take out the negative, or the 2x cubed. I got to take off the negative x squared, and I got to take away the 4. Change the signs. Now, I got to put everything together. And I have to do that negative thing before I can add, combine things. What's the highest exponent here that I see? I got a 3 here, and I've got a 3 here. So, are those like terms? Yes. I got 5 of them there, take away 2 there. How many am I left? So I'd be left with 3x cubed. Okay? What is the next highest exponent going down after 3? 2. So I got a squared here. I got a squared here. So if I got negative 3x squared and I got another x squared, I put those together, what do I end up with? I got a negative 3 and a positive 1. Last I checked, that would be a negative 2x squared. Is there anything else left? Yeah, there's just that minus 4, so it would be minus 4. That's it. That's all that there is to it. Okay? You're just putting together the things that are the same. If there's a negative out in front of it, making sure that the parentheses are all in the right spot. Or not the parentheses, the negatives are in the right spot, sorry. It's not a bad thing. It's just making sure that you can sort everything out and put it into places that it needs to be. So, let's give this a try. What I'm going to do is I'm going to give you a few minutes here, and yeah, I'll give you a minute and I want you to do A. Right. So, gives us David. First thing I got to do is write this in standard form. So, what would this be written in standard form? Yep.
Any students who will be going to have their picture retaken may now go across the street. The photographer is located on the stage.
How many x's? Okay, so I got 4x, and then what? Minus 1. Good. Okay. So now, let's see, we come up with Jordy. What's the leading coefficient here? Leading coefficient, coefficient that's out front. First number that we see when we look at the polynomial. Number. No. What's the first number we see when we take a look at this? Yeah. If whenever you're looking for the leading coefficient, if you have it written in standard form, all you got to do is take a look at what's out front. Just like what you'd say it. If I want to say 4x to the fourth, I'd start off with 4. So the leading coefficient here is going to be the 4. Okay? So the next thing is constant term. So we don't want to pick on you again. So we'll end up going, Mr. Anderson, what's the constant term here? Yep, -1 right there. That's all it is. Okay? So take a look at the next one. Okay. And I need to classify that by degree. So, Kitty, what degree polynomial is B? You're right. Highest exponent. Highest exponent identified is 3. So that means that for this one here, it's going to be third degree. So, let's see. Got 2 there. Riley, how many terms does this thing have? Well, how many things do you see there if I want to classify -3x by degree in the number of terms? How many things are there? 1. So this is a monomial. Easy enough. You just got to remember what the terms are going to be. Stop that. It moves again. So, let's take a look at the next one. So that puts us at Haley. If I take a look at the next one that I have here, what degree polynomial is this one? 2. Absolutely correct. The highest exponent I see is 2, so this is a second degree polynomial. Whoops. Learn how to spell, that always helps. And now I need to identify the number of terms. So, Mr. Garthis, how many terms do we got out of this? I got 1, 2, 3, 4, 5. Okay? Close. Are any of them like terms? Are any things there the same? You know which ones are the same? I got an x squared here, I got a plain old x here, I got a 10 here, I got an x squared here, and I got a plain old 1 there. So those two could be added together and we would end up with 4 terms, which is what? They're quad, it's, yeah, I would just say 4 terms by the number of terms. You don't have to worry about the word. Yes, sir. Are they the same things? Ah. So this 10 here and this 1 over here, they're numbers, right? So they get combined together. So it's not 4, it is really what? Trinomial. Three of them. So not only do we have to make sure that we combine them, we got to make sure that we combine everything that's there. All right, so let's try this. I'm going to give you a minute or so here, and I want you to add D together. Go. What you got? Okay, so it's addition. All I'm going to do is combine the things together that are the same. What's the highest exponent that you see? Okay, so I got the fifth degree over here, and I've got another fifth degree over here, correct? So if I add those together, what do I get? There you go. 5x to the fifth. Okay? Those are gone. Right? I got a question for you, though. There was a negative in front of it. Do I have to concern myself with that? I do got to concern myself with that. So that means it's going to be x to the fifth, but it's going to be a negative 3 and a positive 2, right? So that would end up being negative 1 x to the fifth. So watch signs. If anything kills people in this, it's the signs. So what's the next highest term that I see? 2. Okay, I got a 2 here, and I've got a 2 there. So my question would then be for you is, when I combine those together, what do I get? You say 1? But I've got a 2 here, and what kind of a 1 do I have here? Negative. So it's a positive 2 and a negative 1. So positive 2 and negative 1 gives me a positive 1, right? Add them together. So I got to add 1x squared. Then those are done. What's left? Plus 1. Now you could also see this written as minus x to the fifth plus x squared plus 1. You wouldn't have to have those coefficients in front of it. So I'm going to give you another minute, and I want you to take care of E, do the subtraction. So, Eli, what you get? No idea? Okay, what's the highest exponent you see? 3. So I got one here, and I got one here. Now, before I go and combine like terms, should I take that negative sign and distribute it out to every single one of them? So that means that my 1 minus x cubed is going to stay. This goes to negative x cubed minus 2x squared plus x. Okay? Yeah, so add the rest of it together. These go here, so I get minus 2x cubed minus 2x squared. Those cancel out, plus 1. And there you go.